What spurred me to this topic was an increase in fatalities from belt conveyors in the mining industry over the course of the first part of this year. And that's, of course, troublesome. And there's always lots of new things that we can do to help prevent injuries. But what I wanted to talk about today is that sometimes some of the things that we've always done are quite helpful. So that's why we titled this webinar the Top 5 Old School Conveyor Safety Tactics. We wanted to talk about the things that maybe you've always done, maybe you could do better, but really reinforce those core basic principles in keeping workers safe when they're working around belt conveyors. If you've joined one of our live classes, if you've been through a webinar before, if you've taken any of our online courses or read our books, you've probably heard of some of these concepts. And we're going to talk about them again today for one simple reason. And that reason is because the things that we're going to talk about and have been talking about for many years at Martin Engineering are effective in reducing the risk of injury. You should be able to implement or reinforce some of the things that you're already doing or increase some of the things that we're going to talk about. Also, we're going to recognize some of the shortcomings on some of those basic topics that help prevent the risk of injury from conveyor belts. So here's what we're going to cover. First, I'm going to discuss the specifics of 4 pretty common tactics. Now, you might not have really put words to what these 4 things are. We're going to do that today. We're going to put a title to the 4 basic tactics to keep workers safe around conveyor belts. We're going to talk about each one of them. We're also going to recognize those shortcomings of those 4 tactics. So these 4 tactics are probably things that you might have kind of been doing to a degree before. But what I want to share with you is some of the examples of when they don't work or why they might fail. And then finally, we're going to talk about a 5th highly effective tactic to reduce the risk of injury around belt conveyors. I wanted to share this with you. This is a diagram that we've put together, and it shows with belt speed and the typical adult's reaction time, how far a rolling component can move depending on what your reaction time is and the speed of the belt, and give you an idea of how much movement there is in the time it can take you to react to being pulled into a conveyor or being caught in the nip point of one of the rolling components. So I've got 4 different belt speeds that are represented by 4 different colors. The black line that you see at the top is the fastest belt speed example I have, and that's 1,000 feet per minute. The slowest belt speed that I'm showing is the bottom, which is blue, and that represents a belt that runs at 200 feet per minute. Across the bottom of the graph, you've got different reaction times. And then along the top left, running from bottom to top, is the distance in feet that the belt will travel depending on the reaction time and the speed of the belt. This is something that I would definitely share with your employees as well. Just really bring some awareness to it. Now, for many years, we've been measuring reaction time, and our average reaction time of a typical adult is about 0.8 seconds. Now, what that means is that in the time it takes the brain to send a message to a hand, to tell that hand to drop a tool or to pull away from a pinch point, that takes time for that message to be sent. On average, it's about 0.8 seconds. Now, Olympic sprinters, if you watched the Olympics this summer, you might have seen some coverage on this, but they talk a lot about the reaction time between the starting gun and the time the sprinter actually makes his first movement out of the blocks. Olympic sprinters typically have about a quarter of a second of reaction time. But in mining or in process plants working around conveyors, not many Olympics athletes taking on that kind of work after the Olympic Games. So on average, we come up with about 0.8 seconds. Now, if you take that 0.8 seconds and cross it with your speed of your belts, so you should have some sort of an idea of what the conveyor speeds are that you're working around. Let's just take an example of a belt that runs at about 600 feet per minute. So that would fall somewhere in here. So if we cross our 0.8 seconds with a belt that runs at 600 feet per minute, we're about right here. When we bring that over to belt travel, what that tells us is that if I've got a reaction time of 0.8 seconds, the conveyor belt that I'm working around runs at 600 feet per minute, I've got about 8 feet of travel from that rolling component, from that belt, that will happen before my brain can tell my hand to drop a tool or to pull that hand away from a nip point. So just wanted to show you, really how much risk there is around these fast-moving conveyors. Now, the faster the belt moves, the more belt travel you're going to have, the slower your reaction time, the more distance in belt travel you'll also have. All right, so there's 4 basic conveyor safety topics. We've talked about them for many years. They're kind of tried and true. These are these old school ways that old school things that you can do to help keep your workers safe. Number 1, we're going to put PPE. Now, PPE is one of the things that you can incorporate to help keep workers safe. Number 2, I would include lockout, tag out, test out. I'd also include block out a conveyor. Now, one way that I kind of summarize all these things is instead of PPE, I call number 2 PPP. Let me explain. PPE is that personal protective equipment. PPP are the policies, procedures, and protocol that your plant might have to help prevent injuries. They're specific to each plant. And they're the rules. They're the things that you tell your workers to do to help prevent them from getting hurt. Number 3 is training. Absolutely. We've got to train people on the hazards of conveyors and how to prevent those hazards. We're going to talk more specifically about each one of these. And then number 4, guarding and e-stops. And I would summarize that as, if I'm teaching a live class, I always summarize both of those things as well as startup alarms or horns as safety equipment. So those are those 4 old school basics of conveyor safety that many of you are already doing. And it's really things that as new people enter our industry, we've really got to hone those 4 things. So number 1, PPE. Number 2, PPP. Number 3, training. Number 4, safety equipment. That would include guarding, e-stops, startup alarms, and things like that. So PPE is pretty remedial stuff. We're not going to spend much time on it. Specific to conveyors or in a mine or process plant, certainly must have hard hat, boots, safety glasses at a minimum. You also might need hearing protection. Gloves and long sleeves are typically kind of standard practice at most facilities now. That doesn't mean that you necessarily must do that, but it's really becoming common practice. Third, I want to talk a little bit about proper attire, and I want to talk specifically about hoodies, baggy sleeves, long hair, jewelry. There are instances where workers got sleeves or hooded sweatshirts or baggy clothes caught in the nip points of a conveyor belt or caught up in a tool that they might be working with. So you've got to be aware of those hazards as well. I want to talk about number 2, policies, procedures, and protocol. And I mentioned earlier, lock out the conveyor belt before you work on it. You should also tag out that conveyor belt. Anybody that's working on it should be putting their tag on there. You should have specific policies on who can remove a lock or a tag. And you should be training your people on what that protocol is to remove someone's lock or tag. There's instances where, in most cases, somebody can pull that lock off other than the worker. But in order to do that, there's certain protocol that you must have written down to make sure that it's a supervisor or the person's been contacted or somehow that somebody else can remove a lock. You should also test it out. You should ensure that it is indeed de-energized. Now let's talk specifically and a little bit more about de-energizing a conveyor. When you lock out a conveyor, when you tag out a conveyor, when you test out a conveyor, what you're eliminating is that electrical energy that's used to run the conveyor belt. When a conveyor belt is stretched from pulley to pulley, it's under tension, and that tension will also create what we call stored energy from the stretch of that belt. When you lock out, tag out, test out a conveyor belt, you've not eliminated that potential or that stored or stretch from the belt. So when you have that stored energy or that stretch from the belt, in those instances, you should make sure that you're using what we call a blockout procedure. When I teach live classes, I always ask the group that I'm in front of to explain their company's blockout procedures. And most of the times I get a bunch of blank stares back at me. Let me talk a little bit about a blockout procedure. So you see the diagram on the screen, and I want to kind of go through this example. Let's assume that your plant's running, your mine's running fine, and all of a sudden you get a boulder, a big piece of material, or you get material to pile up because of spillage at the tail pulley, as we see at point 1 in this diagram. If that rock, boulder, or pile of material were to wedge between that tail pulley and the belt, it's possible that it could stop the belt. When that belt stops, you're going to send a crew in there to clean up that pile of material or get that rock from wedging into that pinch point. So before those workers would go into that situation, of course, they would lock out the conveyor, they would tag out the conveyor, they would hopefully test out the conveyor, they'd have all their PPE on, and then they would start digging out that material. If they don't block out the conveyor belt, then they're at risk of this stored energy, because what's not happened is the stretch that you find on the belt. In the example that I'm showing on my screen, the head pulley, which is right here, is the drive pulley. The drive pulley, with its lagging and the drive, grips and pulls the belt. So the high stretch on the conveyor belt is on the top side, represented by 0.4 on our drawing. If I don't block out that conveyor belt by clamping that belt and rigging those clamps up to some structure to prevent that stretch from unexpectedly being released, I'm putting my workers in great danger. So let's take this example. If our stretch is on the top side of the conveyor belt, my workers go in and they lock it out, they tag it out, and they start digging out at 0.1 or 0.2, which way is that tail pulley going to turn once that material is freed from that blockage? Is that tail pulley going to turn counterclockwise, or is it going to turn clockwise? In this instance, because the stretch is on the top, let's kind of suss this out for you a little bit. So this is buried in material. It's totally seized up, no movement in that tail pulley. Guy comes out, gets his shovel, gonna start digging. Not sure why I put a smiley face on the guy. If he's digging out material, he's probably not smiling. So he starts digging, and now because the stretch is on this top side, as that belt turns to equalize the stretch, because the higher the stretch is on the top side, because the tail pulley grips and pulls the belt, this tail pulley is going to rotate counterclockwise. So that worker is at risk. Now, the idea of a blockout procedure is to block this belt with a clamp here and here to eliminate any of that unknown movement or that potential stretch in that belt from moving that tail pulley unexpectedly. Now, this might seem like a strange situation and uncommon. I got to share with you that unfortunately, earlier in this year in the U.S. in the mining industry, there was a fatality from a worker working on a tail pulley, cleaning out spilled material. That conveyor was not blocked out, and MSHA does have specific regulations that says that if work is to be performed on any piece of machinery that has the potential to move, it must be blocked out. In this situation, there was not a blockout. There wasn't clamps on the belt. That tail pulley moved unexpectedly, I assume as the tension was released. Unfortunately, pulled the worker in, and he suffered fatal injuries from that. So it's the consequences of this is significant. So we don't want to overlook this blockout procedure. You want to clamp that belt effectively in the spaces that I showed you, clean out the material, and then once the workers are removed from the area and it's safe to do so with proper training, those workers can slowly let those clamps, that rigging, allow that to turn on under their control rather than the control of the tension of the belt. Let's talk number 3 real quick here about training. And I've been doing training for adults for many, many years. And I got to tell you, I think it's one of the more effective things that you can do to keep workers safe. I think it's one of the more effective things that you can do to just develop workers in general. But there's a shortcoming to training. And that shortcoming is that training alone does not guarantee that the worker is going to do anything with the training. So you want to make sure that your training is quality training that certainly educates the learner, but it's got to do more than just educate. It's got to motivate them to change their behavior. So you want to make sure that when you're doing training, you're really trying to create that training in a way that they come to the best conclusion, because it's human nature that we don't let someone else change our behavior. We can only change our behavior under our own decision. So if you're doing training, you really want to try to make it more impactful than just sharing information. You've got to get discussion. You've got to get the people to convince themselves that what you're explaining to them is in their best interest to execute and get them to change their own behavior. So I want to give you some specifics on guarding and emergency stop switches. They're both excellent ways to reduce the risk of injury. But there's some specifics that you should be aware of to ensure that they're as effective as they can be. So let's start a little bit here. Let's talk about guarding. And the first thing I always mention about guarding is we want to make sure that the guarding cannot be a hazard itself. I'll share a story with you. Many years ago, I was sitting in the office one day and we hired a new person in the office, and he was an inside sales rep. He had never seen conveyors before, never worked around conveyors before. He was in kind of a newer role, and I asked him. I was going to a nearby plant, and he asked if he could join me so I could show him some of these things that he's been seeing in catalogs and talking to people about. So I took him with. Happy to do so. Got him a hard hat, got him his boots, got him his gloves, had all our PPE. I also, real quick, did some training with him. It was pretty short and pretty sweet. It was basically on the truck ride over. I told him, do this, don't do this, don't do this, don't do this. So we checked off that. Now, we weren't doing any work on this conveyor. I was just going over to take a look at some things. So I didn't get into any type of a lockout, tag out, any type of thing like that, because we weren't breaking the plane of the conveyor belt. We get to the plant, and I'm very familiar with this plant. I've been there many times. I knew this facility was well guarded. They had just done a major guarding upgrade, and I knew that this was a pretty safe plant. So the new guy was with me, and he goes to the tail pulley of this conveyor belt, and they had the tail pulley was fully enclosed with a guard, and he wanted to see that tail pulley moving. He wanted to get a better look at that tail pulley. And just before he asked me, the conveyor shut down, and he asked me, he said, this guard was hinged. Can I lift this guard to take a closer look? And I said, well, we talked a little bit about breaking the plane of the conveyor and when it's safe to do so, when it's not safe to do so. And I said, even if this belt were running, it's typically an okay practice to inspect a conveyor belt by opening a door. In this case, this conveyor wasn't running at all. So I said, it's okay for you to do that. Just don't stick your hand past that threshold of where that guard would be. He was good with that. He was fine. So he put his hand on the handle, put his other hand on the back side of the guard, and opened the door like that and pinched his fingers in the hinge that was created from how those guards were installed. So off we go to the emergency room where he needed to deal with his flattened fingertips from pinching his fingers in that guard. So when I say we don't want a guard to be a hazard itself, you really got to examine that guarding and make sure, hey, this is equipment that I'm adding. Workers are going to interact with this equipment. How can I make it so this interaction doesn't cause an injury that we didn't kind of recognize in advance? Guarding cannot be a hazard itself. You want to make sure that a worker can't reach, and we use the acronym AUTO. It's a quick and easy way to keep workers remembering that you can't reach around, under, through, or over a guard. So we use that acronym of AUTO just to make sure it's a little more top of mind and a little easier for workers to remember that they can't reach under a guard, they can't reach around a guard, they can't reach through the guard, and they want to make sure that you can't reach over the guard. So just an easy way to try to remember that. Number 3, guard should stand out in color. It doesn't have to be yellow. I've never seen any regulations from any safety organization or governing body that says the guard must be yellow. However, it does need to stand out in color, or should need to stand out in color, depending on who governs you. One of the things that we see a lot of people doing now is painting their guard field black, but the frame of the guard would be yellow. And what that does is that black field allows for a little bit easier visual inspection of the equipment that you're guarding. When you paint the field of the guard a high visibility color of yellow, it really reduces workers' ability to see past that yellow guarding to the equipment to do any visual inspections. Number 4, it should, and in some cases must, require a tool to remove the guard. So depending on where you're at in the world, what industry you're working in, who your governing bodies are, guards should or must require a tool to remove the guard. What I mean by that is that a worker should not be able to just walk up to a guard and pull that guard off. It should require that he must use a tool to remove the fastener that holds that guard shut. Okay, number 5, catch baskets for return rolls. This is important. Return rolls on a conveyor belt. If that return roll is less than 7 feet in elevation, that return roll must be guarded. Anything above 7 feet, those pinch points on a return roll are far enough away that it typically wouldn't cause injury to a worker. If they're below 7 foot, you've got to guard them. You got to guard the pinch points. In addition to that, I want to talk specifically about catch baskets. If a return roll is over a roadway, if that return roll is over a walkway, if you can walk under the conveyor or you drive under the conveyor, doesn't matter how far up in the air that return roll might be, it's also got to have a catch basket. You're not concerned about the pinch point at that elevation, but if it's over a road or a walkway, you have to reduce the risk of that roll falling unexpectedly. I had a conversation with someone, I recall it very, very clearly, about a year ago. They called me up and asked about that. What's the rule on that? And the reason they asked is they had a return roll fall from an elevation and just miss a worker who was down below. All right, let's talk a little bit about emergency stop switches, and I'm going to give you some real quick recommendations on emergency stop switches. We'll move over here to this side of the screen if you're taking notes. Number 1, you want to test for slack in the cable. So it's not uncommon to see cables that might have a little bit of slack in them. That cable can't have any slack in it. It's got to be tight like that. And we use what we call the wingspan method to test for the slack in the cable. And the wingspan refers to the distance between hand 1 and hand 2. And the idea is put hand 1 on the structure of the conveyor belt and hand 2 on the cable, and very, very slowly pull that cable to test if there's slack in that or not. Once you pull that cable, that conveyor belt should deactivate. If it's not deactivating within a couple of inches of pulling, you've probably got some slack in that cable that's not going to be acceptable. So you want to test that. If you're not doing that, if you've never done that test, that's something that you should probably be considered to do here. You want to also measure for what we call runout. When that cable is pulled, it doesn't stop the conveyor belt. It de-energizes the conveyor belt. That conveyor will continue to run until it comes to a complete stop. So once you deactivate or de-energize the conveyor with that pull cord, that belt continues to travel a little bit until it slows down until eventually it comes to a stop. The time it takes for that belt to come to a complete stop is called runout. That runout should be measured, should be documented, should be shared with your staff so they think, hey, this e-stop doesn't stop the belt, it de-energizes the belt. You want to inspect your clamps and your cables. You want to make sure that the cables are in good condition. You want to make sure that the clamps are in good condition and that there are two clamps. You want to inspect the distance and elevation of each one of those. And I'm going to talk more about that here with some diagrams. Before I do, let's jump back to guarding real quick. Just a couple of examples. Here's some fasteners to hold a guard in place. I'm concerned with these fasteners because these zip ties that they have on here, they do require a tool to remove as long as they're not old and have become brittle. If a worker could come up and just with his finger snap that zip tie because it's became brittle or because it's too light duty, that's a concern that I need paying attention to. Also in this picture, what I do like is that it stands out in color. Now you can see it's difficult to do visual inspections because of that high visibility color. So in this example, I would maybe consider painting this field black. If you paint the field of a guard black, it makes that visual inspection a little bit easier. I'm also going to pay really close attention to what I got going on here. I told you about a story where a worker caught his fingers in a hinge very similar to that. So this guard at first sight might look pretty great. However, it could be a hazard itself. It doesn't necessarily require a tool to remove. You've got to look a little bit closer at those instances to see if it's satisfactory. Also wanted to share this with you. There's a rule on how big the opening should be compared to how far it is from the moving equipment. So the greater the size of the opening, the further away that guard must be from the rotating equipment. If the guarding is very close to the rotating equipment, that opening needs to be much smaller. And that's what this worker is demonstrating in this example. He's using a tool. It's called, some people call it a gotcha stick. You can get those online. If you do one of our live classes, we send them along with the class. But that's one way to measure it. This is a guard. These guys, this is up in a cement plant. And I was about to go up to the stairs that you see on the right-hand side. As I passed this return roll, I wanted the guy that was with me to snap a quick picture. They were super proud of how well they regarded their plant. And that was a role that I could certainly reach around. So you want to look at these guards with a very close eye. The other concern I would have with this guard is simply the sharp edges that it has. That could create a laceration. Real quick, taking a look at safety clamps and cables. This cable has deteriorated, so it does need to be changed. Safety equipment needs to be kept in its original condition. The cable doesn't have to have a protective coating on it like this. However, if it does have a protective coating, it needs to be in good condition. So this cable should be replaced. Talked a little bit about where the elevation of that e-stop or that cable should lie. That's going to be in this green area. So it's a measurement off the floor or walkway of where a worker would be. And that cable should lay somewhere between 36 inches from that walkway, from the bottom of that walkway, to 60 inches. So we want somewhere between 36 inches off the floor to 60 inches off the floor, which is this area right here. Somewhere in that green area is where the elevation of that cable should be located. Let's talk a little bit about this fifth tactic. When do people get hurt around a conveyor belt? I'd refer you to a study that was done prior to MSHA. There was an organization called the U.S. Bureau of Mines. Now, the U.S. Bureau of Mines tasks were different than MSHA. Than MSHA's tasks. The U.S. Bureau of Mines, which is it's no longer around, did research for the Department of Labor to make sure that, hey, this is what we found. There was a study that was done by the U.S. Bureau of Mines many years ago, and it was over the course of 4 years. It was done by a gentleman by the name of Harvey Pageant. And in this study, this former mine inspector that was doing research for the U.S. Bureau of Mines studied over the course of 4 years what workers were doing when they got hurt from belt conveyors. And what they found in this study is that I think it was almost 80% of the workers that got hurt around conveyor were either doing maintenance on conveyors or cleaning around conveyor belts. So that really leads us into our fifth tactic, which in our opinion is the most effective way you can reduce conveyor belt injuries. Every single time there's a conveyor belt injury or accident, we research that at Martin Engineering. We make sure we fully understand what was going on there, and we really look deeply at the root cause. In our estimates, it's probably greater than 80% of workers doing maintenance or cleaning around conveyor belts that get hurt around conveyor belts. So that fifth tactic to keep your workers safe is to really prevent that cleanup and make maintenance as safe as possible. There's a few ways that you can do that. To make maintenance as safe as possible, some things that you could do is you could ask contractors who have maybe more experience and more training on their equipment to do that specialized maintenance. That eliminates the reduce of your workers who may not have that specialized training and specialized experience on belt conveyors that might be needed. The other thing you can do is make sure that you're looking at equipment that is designed to make maintenance quick and safe and easy. An example that comes to mind real quick are now belt scrapers are designed, some belt scrapers are designed where you can access them from the side, pull them out from a cartridge, change the blades out, and then reinsert the cartridge without breaking the plane of conveyor. So just an example of things like that. The most effective way to reduce conveyor belt, reduce maintenance or make maintenance safer, and then reduce cleanup. Spillage around a transfer point, I think, in my experience, is the most hazardous thing on a belt conveyor. I can't tell you how many injuries, how many fatalities that I've researched, and they've happened because the worker was cleaning up spillage at a transfer point where one belt dumped onto another. So you've really got to make sure that load zones, our transfer points, are designed and maintained properly to prevent spillage. If you've got spillage, you're putting people in harm's way every time they clean it up. And there's been countless injuries and fatalities when a worker was shoveling up material around a belt conveyor, got that shovel stuck in a pinch point, and put him in an injured situation that sometimes can be catastrophic. Thanks for joining, everybody. Appreciate your time. Stay safe, and we'll see you soon.